on the ground, every animal that died in its carcass, and every pile of poop that the animal left, if that never went away, if that was just
about corpses.
yeah, exactly. That's what I mean, carcasses. You know, we wouldn't be able to exist. What is it that finally breaks down those materials even after the animal carcass has been picked clean by all the scavengers? It's fungi that break it down and reduce it to elemental elements that can be recycled and reused in the soil. So you can have decomposing fungus, you can have fungus that's parasitic, it eats off things that are still living. You can have, I did a walk last week about lichens, fungus that takes up farming. It finds cyanobacteria, blue-green algae, and decides cyanobacteria is an awfully delicate organism. It needs to be in water, it can't dry out, it can't have too many temperature extremes, but we'll take up farming and we'll build a barn and hay, and the cows can then survive in snowy so in other words, it forms a structure around the algae that we call a lichen. Only about 7% of it is the blue-green algae. The rest of it is a fungus, and it takes on many forms, from powdery green coatings that you see on the trees to big leafy lungworts that we have around here to branching wolf lichen and Methuselah's beard and witch's hair. And that's a third way. This type of fungus makes its living called being mycorrhizal. Mycorrhizal is a relationship that's a mutual symbiosis. So there's a fungus organism that's like a net that's under the ground of fibers extending out. You can't see it. I use the analogy on my mushroom walks that imagine a cherry tree. You all can visualize what a cherry tree looks like. Imagine a cherry tree laying on its side, covered up by the ground. You never know the cherry's there until it's cherry season. And then instead of cherries ripening on the tree, they pop up out of the ground because the mushroom is the fruiting body of the organism. And instead of having a seed surrounded by a fruit, it's got microscopic spores that look like a powder, and many times they're released from a fleshy body that we call a mushroom, and some mushrooms are edible. Mycorrhizal means that this particular fungus has threaded its network, its tentacles that are called hyphae, and have connected with root nodes of these trees, and they help one another. It's like a relationship where it's a nice, good, even taking and giving. The tree provides the fungus with sugars because trees do the magic of photosynthesis where they pull the water up from the roots, tons of it, up into the canopy, into the leaves, and mix with sunlight and carbon dioxide, and you get sugar. I've looked at all the chemical breakdowns and studied them. To me, it's still magic, alchemy, how that can happen. That you can take water and sunlight and carbon dioxide and you get, basically glucose, glycogen, sugars, which the tree then sends back down. Well, it spreads it out in the leaves and roots, but then sends it down into the roots as storage to help the tree grow and prosper when there's cloudy days like this for weeks on end and we don't get much sunlight. So the tree shares its photosynthesized carbohydrates with the fungus. The fungus can extract minerals out of the soil that are harder for the tree to utilize. Magnesium, phosphorus, nitrogen, potassium, and feeds that into the tree, as well as providing, paradoxically, antifungal protection. Because if you're a tree, everything wants to attack you and eat you. Insects, bacteria, viruses, parasitic fungi, all want to get at you. And if you're a tree, unless you're in Lord of the Rings, and what were they, Ents? Ents, you could get up in the tree army and walk away. The tree, you can't get up and do anything. You just have to try and fight off the attackers. Well, this fungi, the mycorrhizal relationship, they actually provide chemical protections against parasitic fungus to help the tree withstand invasions and attacks. So it's a real shared giftedness between two types of organisms, and we call that a mycorrhizal relationships. And the yellow wax caps are doing that for these western red cedars that they're underneath. So, everything is smarter than we think it is. One of my big axioms of the natural world, that, and there's a reason for everything. And the third one is that everything you find in nature is found where it should be, and it's doing what it should be doing, or it would be dead. It wouldn't be making it. So anyway, the complexities, everything smarter than we think it is, are, you know, in the past few decades are really coming to light. What's going on underneath the ground with the fungal relationships and interactions helping plants, and what's going above the ground with trees communicating with one another via pheromones. Suzanne Simon, University of British Columbia prof, has a great book out called Finding the Mother Tree, and I think she might be on YouTube as well. And she's been exploring the communications and the goings-on between trees, between one another, trees and other plants, and trees and fungi. It's astounding, you know, and we've been, as the human species, blithely ignorant of it for most of our time on Earth, but now we're starting to recognize the great complexities of it. So there's a lot more going on. Everything's smarter than we think it is, and everything, there's a greater complexity as part of a corollary to that than what we think. So let's head up and take a look at